Very good afternoon. Myself Sunil Kumar, Assistant Professor in IIMT College of Polytechnic. Today I am given a lecture which is very important topic, stress and strain in the field of mechanical engineering and civil engineering. Now I will share my PPT. The content of my PPT presentation for today is stress, terminology related to the stress, type of stress, strain, terminology related to strain, types of strain, relation between stress and strain diagram. So stress and strain is a very important topic. Before starting the strain, the name, as you know, the name of the subject is mechanics of solid, advanced mechanics of solid, and strength of mechanics. This is a common names related to these subjects. So if you're talking about mechanics of solid, it is basically branch of mechanics which is related to the deformation of the body. Deformation of body, if you're talking about the deformation of the body, any deformation with related to the force. If we do not apply any force, there is no deformation. So deformation के लिए without any force we cannot deform any body. So then means effect of force. Effect of force yani how we applied the force to affect the body. So there is some ways that we affect the body. Now first is the pull, second is the compress, which is known as compressive force, then twisting force, next is the bending force, and fifth is the breaking, cutting or shear force. So in my presentation I am discussing about these effect of forces: pull, compression, compressive force, twisting force, bending force, and these forces. So stress, if you're talking about simple definition of stress, so stress are expressed as the ratio of applied force divided by the resistance area. So these forces, so force in this chapter, stress and strain, there is a confusion regarding the force. It is a scalar quantities or vector quantities, but near about stress is as compared to the vector quantity. In further slide, I am also discussing why we are not saying is a vector quantities or scalar quantities. Give another techniques that is called the tensor. So why in mechanics of solid strength of material is used as a tensor subject. So if you're talking about the torque, which is T is equal to force into distance between the forces. If you're talking about the bending force, which is equal to F into D, will produce the movement. So next, coming to the next slide, this is a definition. So stress are expressed as the ratio of applied force divided by the resisting area. In discussion about the mathematically, so sigma is equal to force divided by area. If you're talking about the unit, as you know, the unit of force is Newton and area is the meter square. So finally, the unit is Newton per meter square, or which is known as the Pascal. If 1 kilopascal is equal to 1000 Pascal, or 1 megapascal is equal to 10 raised power 6. Then come to the next slide. Also, terminology related to the stress capacity, stress load. I'm discussing so further. Yeah, there is a type of stresses. Type of stresses means what type of stresses are generated. So first is the normal stress. Again, subcategory is the tensile stress, compressive stress, Then combined stress, it is subcategory is shear stress and torsional stress. If you're talking about the normal stress, according to the definition, it is the stress which acts in a direction perpendicular to the area. It is represented by sigma. So the normal stress further divide into two categories, tensile stress and compressive stress. If you're talking about the mathematical expression, then mathematical expression, let P is equal to pull applied force, A is equal to cross-sectional area, L is equal to original length, delta L is equal to change in length, sigma is equal to stress, and E is equal to strain. Then tensile stress is equal to tensile load divided by cross-sectional area. So tensile stress is equal to sigma is equal to, again, which is equal to P by A. And tensile stress, tensile strain, so tensile strain, which is known as the increase in length divided by original length, which is known as dl by L. So sigma is equal to, then sigma, if you're talking about compressive stress मतलब कि pull in tensile. If compressive की बात करते हैं, if you're talking about compressive, when the push force is applied, so push force मतलब P, push force P divided by cross-sectional area A, which is known as compressive strain, which is known as equal to delta L by L. So any change in length divided by original length. Then combined stress, shear stress and torsional stress, which is also discussing. So normal stress, tensile stress and compressive stress. So normal stress, resisting area is perpendicular to the applied force. If you're talking the tensile stress, so it acts normal to the area and pull on the area. So this is known as the tensile stress. If you're talking about compressive stress, it means stress induced in a body when subjected to two equal and opposite pushes, as a resultant of which there is a tendency of decrease in length of the body. So decrease in length of body means we are applied equally force in push direction. So if pushing any object, any bar, any material, then compressive stress is generated. Then it acts normal to the area and it pushes on the area. So this is a very, very important topic. Then combined stress, shear stress and torsional stress. So I'm coming one diagram. This is a very, very, very important diagram which show that tensile stress, compressive stress and shear stress. It's a very, very important diagram. So if we are talking about these diagram, tensile stresses, suppose it is a bar, yeah, it is a rectangular section. If we very simple language, consider a rectangular section or bar. Bar normally say in mechanics of solid, in any rectangular section says the bar with some length, breadth and thickness. That is called, not saying rectangle, it is called as a bar. Bar is a section. So if we consider these pull load, tensile force, these bar consider 2 points A and B. A and B, we applied the pull force, tensile force. So these 2 points, the moment of force increase the length of the material. Or we can say in this particular region, the fiber, the layer of the material will increase the length of these bar. So stress. So in this diagram, I am explain the stress. What is the stress is generated the concept or defining the stress. It's a very, very important thing. Okay, we are considering 2 points A and B. Please listen very carefully. I am explaining stress concept. It's a very, very important thing. So consider 2 points A and B, which is nature is tensile force and delta is the change in deformation or extension of the member. So initially section P, if sum of all the forces, summation of F is equal to 0, summation of Fx is equal to 0, summation of Fy is equal to 0, summation of moment is equal to 0. So if adding these forces, yani summation of moment divided by x plus summation of moment divided by y plus summation of x, y and z is equal to plus summation of z is equal to 0 is equal to 0 means it is a static condition. Static condition means there is no movement of the material. So what is the means? If you considering this section only, please look where I am, my mouse is rotating. So this arrow is denoted as P, and here we are considering the force F. F is equal to equal and opposite force is acting. If consider this section, this force P, equal and opposite these segments are generated, which is known as the resistance force. This is a very, very important force. Is P force balancing the resistance force. Resistance force means the material is opposed the deformation to apply the full load. So here, if we're calculating the F minus P, here P, here the resistive force F. So F minus P is equal to 0 in these regions. So F is equal to, for F minus P is equal to 0, then F is equal to P. Yani applied load is equal to resistance force. This is very, very important. So there is no deformation. There is no change in shape and the size of the material of the bar. So if we consider only this section and consider one elemental point, which is area is delta A, and this acting a force which is known as delta F. So stress is equal to, if we're talking exact definition of the stress, then stress is equal to resistance for per unit area. The resistance for per unit area, if you consider only one point, there is so many points, so many regions are occur in the resistive force area. So consider any one point, which is a area is delta A, small delta A, and force is the delta F. Then sigma is equal to limit delta A tends to 0, delta F upon delta A. Again, I am repeating, sigma is equal to limit delta A tends to 0, delta F upon delta A, where sigma stress is not constant throughout the section. Why? Because the nature of deformation is changed inside the region. Every layer by layer deformation is changed. So stress is always changed. So we cannot say that the stress is constant in particular region. So sigma is equal to limit delta A tends to 0 when delta F upon delta A. Then sigma is equal to, if area is very small, then sigma is equal to the dF by dA, which is very, very important. So sigma is equal to dF by dA. So we calculate in dF. So dF is equal to sigma into dA, which is very small elemental area. If you're talking total area means integrate both sides. So integral of dF is equal to integral of sigma into dA. So then we're talking about concept of average stress. Average stress means F is equal to sigma into A, where sigma is equal to F by A. When he applied force or resistive force divided by cross-sectional area. So here stress is defined in this region. I'm discussing already the unit. So coming to the next slide. Strain. Strain defined as change in length divided by original length. If any material, any body, we applied the tensile load, so the actual length of the material, when we applied any pull load, the length is increasing. And before the length and after applied the force of the length, then change in the length divided by original length, that is called the strain. So strain is a definition is change in length divided by original length. So when a body is subjected to some external force, there is a change in the dimension of the body. The ratio of change in dimension of the body to its original dimension is called the strain. Then terminology related to the strain: longitudinal or linear strain, compressive strain, and tensile strain. Longitudinal strain, when change occurs in length direction, longitudinal direction, yeah, linear direction, that is called the longitudinal strain. Compressive strain matlab when the force is applied in push condition, opposite in direction, that is called the compressive, change in length divided by original length. Then the tension, longitudinal strain, that length and object which is occur the tension. Then again some terms related: shear, infinite strain, finite strain. I'm coming to our next slide. Homogeneous strain, inhomogeneous strain. I'm coming to the directly types of strain. Types of strain: tensile strain, compressive strain, volumetric strain, shear strain. So what is the definition of the strain? Strain means the deformation of a body per unit length is called strain. It is denoted by epsilon. So strain means the deformation of a body per unit length is called a strain. Then come to the normal strain. Before explaining these things, come to the normal strain. So normal strain, how is defined? The ratio of change in length of a body to its original length is called normal strain. Means L plus delta L. Suppose any bar, any member, we are applied the forces, compressive in nature, then actual length is L, change in length is delta L. So L plus delta L minus L divided by L. Normally people say that delta L upon L. But normal strain is defined L plus delta L minus L divided by L. After cancellation of the L, finally get the result delta L upon L. So all the books and notes are available in the form of the delta L by L. But exact mathematical error, 100% correct, is L plus delta L minus L divided by L. Is so the changes of the material, of the dimension, of the shape when we are applied the compressive in nature. So delta L upon L is the normal strain. Then come to the lateral strain. Before slide I am showing the name lateral strain. I am explaining the term lateral strain in this particular slide. So lateral strain means it is the ratio of change in lateral dimension of a body to its initial lateral dimension. Then it's defined as change in lateral dimension divided by initial lateral dimension, which is known as, suppose the actual dimension is capital D. When we are applied the compressive load, the D is changed in terms of minus D. Maybe in horizontal direction, maybe some changes in vertical direction, maybe changes in thickness terms. So the material is deformed when we are applied the load in compressive in nature. So to finally get the result, capital D minus small d divided by D, which is equal to, or say that delta D upon D. Means lateral strain is again change in dimension divided by original dimension. Then come to the point volumetric strain. Again, volumetric strain is defined the ratio between the change in volume to the original volume of a body is called volumetric strain. Suppose a cube, 6 faces, we are applying the load in compressive in nature, there are changes. Either the material will be, because the material is constant in any dimension, either we are consider square, we are consider rectangle, we are consider any dimension of shape. When we are applied the any load in terms of tensile load, in terms of compressive load, the net material is constant, only shape is changes. So this is very, very important thing, how the shape is vary from which direction, either X direction, either Y direction, either Z direction, either in change of length, either change in breadth, either change in thickness. So these show the behavior of the material or change in the dimension of the material in the given specific region, specific shape. So volumetric strain also define the ratio between the change in volume to the original volume of a body is called the volumetric strain. So come to the point, last is the shear strain. It's a very, very important thing. How to shear? You all are know, when any special, any cube, any square, any rectangle, when one face is fixed, any surface, and or we can say the movement is the zero, and applied the force in either any face, so the material, the shape is deformed, the shape is shifted in other positions. That is called the shear strain. So exact definition is the shear strain is an element subjected to shear force does not change in length but undergoes changes in shape. So shearing force causes shear deformation. So when we are suppose a rectangle ABCD, A and D, the axes are fixed. So after B and D, when we are apply any force at the position of B, so B and D are shifted, new position, suppose B dash and D dash, and make an angle of the phi. So tan phi is equal to DD dash, yeah, CD dash, any phase you have considered which is not fixed. So DD dash divided by original length, yeah, which is we have fixed the phase, then DD dash divided by H or CC dash divided by H. So phi is very small, then tan phi is equal to phi. So these are the definitions related to this type of. Again, I am showing one picture. Tensile strain, I am discussing increase in length divided by original length, which is known as DL by L. If you're talking about the compressive strain, the ratio of decrease in length to the original length of the body, that is compressive strain is defined as decrease in length divided by original length, which is DL by L. Then volumetric strain, yani change in volume divided by original volume. So here I am discussing the point types of strain. So tensile strain, this is a rectangle. If you consider A, B, C, D, we have applied a tensile force or pull force F. So the shape is changed or the length is changed. So here the generation of the tensile strain, and this particular point, if we opposite the force in nature or compressive in nature, the change in length divided by original length, also change in length divided by original length. If you consider one cube A, B, C, D, yeah, any volume, then we have applied some forces, there are also some changes. So V is changes to dB, so dB upon B. Here also explain the strain change in volume divided by original volume. So this show the result of the strain conditions. So further moving, here shear strain, I am explaining shear strain just before some few slides. This tan phi is equal to phi, means If any specimen, if one phase is fixed, apply the force in another phase. So these type of free forces are moved in any direction, x direction, y direction, z direction. So change in up new phases. Suppose this is the initial condition when we consider A, B, C, D. This phase is fixed. If you applied the force this phase, then this particular points move new position. If you particular name is B, B to B dash. If your particular name is C, then C to C dash. So C to C dash, yeah, B dash, B dash, C dash divided by original length. So here shear strain or volumetric strain means change in volume, change in dimensions related to the original shape. Then I am coming to the next slide. Relation between stress and strain is a very important term related to the stress and strain because we are using the Hooke's law and also considering any specimen experimental setup to the UTM machine, universal tensile machine, we can find the value of tensile forces, compressive forces, also further data calculated to the stress and strain. So this is a Hooke's law. If stress is directly proportional to strain under up to the elastic limit, that is called the Hooke's law. So mathematically, E is equal to, yani stress is directly proportional to strain. If you replace the proportionality, then stress is equal to E into strain, where E is equal to stress divided by strain. Also, the name of the E is the Young modulus, which is very important for any material property. So numerically, E is equal to, in each and every material, E is fixed, like aluminum, copper, zinc, steel, combination of steels, combination of aluminum. So E already given a tabulated form to the material agencies that the E is equal to, suppose E is equal to steel 210 into 10 pound Newton per meter steel. इसी तरीके से some data is provided to the aluminum के लिए, some data is provided to the copper. Then coming to the stress strain curve, which is very important part in a mechanical engineering. Every material is tested by stress and strain under the UTM machine, universal testing machine. So these curve provide when we are going to test tensile testing. So tensile testing, first we make the specimen, fix it the UTM machine, applied the load until unless fracture, the material is fractured. So in this curve, give the some information related to the material. The curve is plotted between stress and strain. So these initial point 0 to these point is called the proportionality limit. Proportionality limit means here stress is directly proportional to the strain. It means the value of stress and strain is equal these points. If you plotting any axis, any point, that the value of x and y will be same. So these are the proportionality limit, and Hooke's law is valid these condition yahan tak. Until these point 0 to these point, Hooke's law is valid. After that, the material start the deformation. Deformation means the material movement start. Upper yield point, lower yield point, ultimate point, and finally the material is fractured each point. So after fracture, we can check the behavior where cup and cone, and also there the how load applied, how force is applied, the material is fractured. So this is a very important curve, stress and strain. So now these lectures I'm concluding. So this is a very important, again, parts of stress and strain in material science, and mechanics of solids, which can provide the help to designing any component, any parts, any machine parts, any cylinder, any vessel, any IC engine parts. to how much force, how much wearing, how much applications. So these are the total my lectures. Thank you to